So flags in 8051 microcontroller, only 4 flags are there. To start with, we have a carry flag. Carry flag will set if there is a carry from D7th bit to D8th bit. As we know already, if there is a sum exceeds, or if the computation, when we do any arithmetic operation, if the arithmetic operation value exceeds 8 bit, that is notified by the 8051 microcontroller through the carry flag. For example, the content of the accumulator is FF, and if you are adding 1 with the content of the accumulator content will become 0. So meaning 255 plus 1, it is 256. But instead of 256, accumulator will show 0 because the maximum value where accumulator can hold is 255. So the carry will generate and notifies that there is a carry in this arithmetic operation, do something. So we did that something. We looked at the carry flag, and then we have incremented R2 if there is a carry, and then we have used this R2 as a most significant bit in a multi-byte addition. Okay, so single byte result has become multi-byte result that is being notified by the carry flag in the 8051 microcontroller, which is playing a major role in most of the arithmetic operation. The second flag that what we have is parity flag. Being a communication engineers, parity flag is most widely used in the communication. So for example, if we are transmitting number of ones as odd numbers, means in the receiver side we have to receive the number of ones as an odd number of ones. Okay, so if the number of ones are even number, means some bit has changed in the channel, so which might be an error. So we can identify there is something went wrong in the number of bits, something like that. So this parity flag playing a much role in the communication. When we transfer the byte from one location to another location, this parity flag will help us up to some extent. So the parity flag will set if the number of ones in the accumulator is odd number. So in this slide, the number of ones in the accumulator, assuming this D0 to D7 is accumulator, the D0 bit is 1, so number of ones is an odd number of 1. So parity flag will set and notify the number of ones in the accumulator is odd number, hence parity flag sets and made it as an even number. Okay, while communicating this will be useful. We'll discuss that about parity flag much detail while we do communication. Another interesting thing is axillary carry flag. So this carry flag will set if there is a carry from D3 to D4. Okay, so if there is a carry from D7 to D8, carry flag will set. If there is a carry from D3 to D4, then axillary carry flag will set. So this axillary carry flag is very much useful for some BCD addition, binary coded decimal addition. We'll be talking about that soon when we do some arithmetic operations. So a good example here is when 8 is added with 8, that means 1000 plus 1000. So 1 plus 1, 10. So there will be a carry from D3, D4, then axillary carry flag will set. Okay, so we'll see some examples that you can understand much more better. We'll go for overflow flag, most familiar flag, which we are already experiencing. So our flag will set if the positive number becomes negative number, or if the negative number becomes positive number, and divide by 0 exception, our product goes above a byte, then overflow flag will set and notify. The two 8-bit numbers are multiplied, product is 16-bit, notify that overflow flag will set. Now we'll see some examples, right? There are 4 flags. If there are 4 flags, means totally there are 16 possible combinations. All the 16 possible combinations is being tried. Now here, as usual, we have started the coding with org0h, and the program counter is pointing this first line, which is 000. Program counter is pointing 000. And here you see, if you give a semicolon, after the semicolon we can give some comments. Here I am giving the semicolon for representing it in binary to make you to understand. Okay, so our interest is to look at the flags quickly. If we see, moving the immediate constant 05 to the accumulator, which is MOV A, hash 0x05. This is immediate addressing. Moving the immediate constant 05 to the accumulator A, which is first instruction. Moving the immediate constant 1 to register R7, that is our second instruction. Adding the content of accumulator with the content of the R7 and store the sum in the accumulator. The accumulator will have 6. Here no flags will set because number of ones in the accumulator after addition, number of ones in the accumulator is even number of ones. So parity flag will also not set. Okay. So here you can see, and let me do the single step. So here there is a PSW program status word register. All the flags are 0. Go to the view. Here there is something like watch window 1, watch window 2. Like memory window, memory 1, memory 2, memory 3, memory 4. There are watch windows. When I go for watch window, it will ask for enter expression. It will ask for enter expression. So you have to give function. You have to give function key. Okay. You have to give function. You have to press F2. Okay. To enter expression means you have to press F2. When we press F2, there is a possibility for us to edit. Our interest is to watch the carry flag. When you click C, and then if you give enter, the carry flag, because the type is bit, so it is a carry flag, it is bit. Then you need to axillary carry. Enter expression means axillary carry. Yes. Then double click, then parity. For that P, then double click overflow OV. So there are 4 flags, all are bit type, and initially all the values are 0. Like this, we can watch the content of the flag by using watch window, which is also quite interesting. So now we are executing this. We are executing this instruction. So you see, program counter is pointing this. Move accumulator A, which is 5, and move the R7, which is 1, and we are adding. So flag reflects the status of accumulator. One thing you need to understand, always flags reflect the status of accumulator. Now, if there is an arithmetic operation, after performing the operation, it reflects the status of the accumulator. Now addition was happened. So 5 plus 1, 6. So there is no carry flag set, there is no auxiliary carry flag set, there is no parity flag set, there is no overflow flag sets. That's all. So now when you go to the second part of execution, so 28 is the value which is moved to the accumulator, and 8 is the value which is moved to R7, and we are adding the content of R7 with the content of accumulator, and the sum will be in the accumulator. When we perform addition, if you see, 28 is represented as 00101000, and 8 is represented as 00001000. When we add this, 1 plus 1 is 10. So there is a carry from D3 to D4. There is a carry from D3 to D4. Look at the screen, look at the cursor. There is a carry from D3 to D4. If there is a carry from D3 to D4, auxiliary carry flag will set, and then it will notify there is an auxiliary carry which was happened while adding these 2 numbers. That means there is a carry from D3 bit to D4 bit, something like that. Now we can experience this by executing this code. Say for example, moving 28 to the accumulator. Moving 28 to the accumulator. Yes, 28 is in the accumulator, and R7 is having 8. Yes, R7 is having 8. When we add this to, the sum is 30. 0011 is 3 and 000 is 00. The sum is 30. Here you can see the auxiliary carry flag was set because there is a carry from D3 to D4. This justifies how the auxiliary carry flag sets. Here you can see in the register window also, in the processor status word, auxiliary carry flag alone sets. Out of 16 combinations, 1 is over auxiliary carry. Now we check how the carry flag sets. So if there is a carry from D7 to D8, carry flag will set. Purposefully we have made the carry to occur by adding C1 and C0 as usual. When we add the C1 and C0, 1 plus 1, 0. Then 1 will be the carry, then 1, 1, 1. So 1 plus 1 is 11, and there is a carry from D7 to D8. So when we do this arithmetic operation, there will be a carry from D7 to D8. Hence, the carry flag alone will set, that we can experience it now. So when we do the single step execution, C1 to the accumulator, C1 to the accumulator, C0 to R7. In the left hand side, the blue color, we can able to see R7 is C0, accumulator contains C1. Adding this, the content of the accumulator will become, the content of the accumulator will become 81. 81 because 1000, 81, and the carry flag will set. You can see current of the accumulator has become 81 and the carry flag was set. You can able to see the carry flag was set. So carry flags, auxiliary carry flag alone set, carry flag alone how to set, then carry and auxiliary flag both you have to set. For that, again adding this C8 with C8, right? So when we add 8 means 1 plus 1, 10. There will be a carry in D3 to D4. Again here there will be a carry from D7 to D8. So both the places there are carry. Hence both the carry flag and auxiliary carry flag will set after computing this operation. Let me do this single step execution. C8 and R7 is also having C8. While executing this, both the flag will set. You have to see. So carry flag and auxiliary carry flag, both the flag was set, which notifies there is a carry from D3 to D4 in this operation, as well as there is a carry from D7 to D8 in this operation. Fantastic, right? Now our most interesting overflow flag. Here the most significant bit is 0. So it is a positive number. 41 is a positive number. Again 40 is a positive number. Adding this two positive number, the sum will be the negative number because it's 0. Okay, 81 means minus 127. So adding two positive numbers, the sum has become negative number. Hence overflow flag will set and notify that positive number has become negative number. Okay. So doing the single step, accumulator contains 41, R7 register contains 40. Adding these two, the answer will be 81, where positive number becomes negative number. There is no carry, there is no auxiliary carry. Number of ones are also even number of ones, 1 plus 1, 2 ones. So parity flag will also not set. Only flag which will set is overflow flag. While doing this, let us check by doing single step execution. You can see overflow flag alone is set. You can see overflow flag alone is set, which notifies the positive number has become negative number. It is up to us, you can see here, it is up to us to do some necessary action for this particular activity. And overflow and auxiliary carry, as you all know very well, two positive numbers has become negative number. There is a carry from D6 to D7. If there is a carry from D6 to D7, overflow flag will set. Yes, there is a carry from D6 to D7, overflow flag will set, which notifies positive number has become negative number. Along with that, there is a carry from D3 to D4. Along with that, there is a carry from D3 to D4. Hence, auxiliary carry flag will set and then notify. There is a carry in D3 to D4 as well as there is a carry in D6 to D7. So that means if you are doing signed arithmetic, the positive number has become negative number. Kindly make note of it, something like that. If you are not interested in doing signed arithmetic, we don't want to bother about overflow flag. This is very important. It's up to the programmer's choice. If the programmer is doing signed arithmetic, then it is mandatory for him to look at overflow flag. If the programmer is doing unsigned arithmetic, it is not necessary for us to look at the overflow flag. When we are doing BCD, binary coded decimal operation, it is mandatory for us to look at the arithmetic, that is auxiliary carry flag. If we are not doing any BCD, binary coded decimal operations, we don't want to look at the auxiliary carry flag. Now we are discussing about how auxiliary carry flag sets. Okay, so this will very much support to do the BCD, binary coded decimal arithmetic. Okay, we do binary arithmetic now. There is a possibility for us to do BCD arithmetic. Okay, there are instructions called the decimal adjust accumulator, and while discussing about that, you will understand the significance of auxiliary carry flag. Now we are looking at only how auxiliary flag sets. When there is a carry from D3 to D4, auxiliary carry flag sets. That alone we are looking at it. How this helps in BCD arithmetic, that we will be discussing in the following classes. Okay, got it? So now we are expecting both the overflow flag and auxiliary carry flag to set. So let me do the single step execution, and you can see Now 49 and 40C, where overflow and auxiliary carry flag will set. Yes, auxiliary carry flag was set and overflow flag was set. Where auxiliary carry flag was set and overflow flag was set. You can see both the flag was set just because there is a carry from D3 to D4, hence auxiliary carry flag was set. There is a carry from D6 to D7, hence positive number has become negative number, hence overflow flag was set. Okay, and number of ones in the accumulator are even number, so parity flag was cleared. Because 1, 2, 3, 4, there are 4 ones, so parity flag was cleared. Now we are testing overflow and carry. Overflow and carry. Here you can see there is a carry from D6 to D7. There is a carry from D6 to D7. There is a carry from D7 to D8, where carry flag will set. And 80 is minus 128. And this another 80 is minus 128. When two negative number minus 128 is added with minus 128, we are getting the positive number. 0 is considered as a positive number, hence it has become 0. So MSB has become 0. When MSB is 0 means positive number. So here also you can see the most significant bit, that both the negative number has become positive number. In this case, positive number has become negative number, right? Here you see, this is a positive number. 41 is a positive number. This 44C is a positive number. Adding these two, the sum is negative number. Why? Because MSB is 1. The other way around, this is a negative number which is 80 minus 128. The maximum negative value in 8-bit is minus 128, which is 80. Again, the maximum negative value in 8-bit is minus 128, which is again 80. When we add this, the sum has become positive number. So negative number has become positive number. To notify that, overflow flag will set. And there is a carry from D7 to D8. To notify that, carry flag will also set. Let us check this by doing single step execution. Move A, 80, accumulator has got 80 and R7 has also got 80. And when we are performing the addition operation, we are able to see the carry flag as well as overflow flag, both are set. We are able to see the carry flag and overflow flag both are set, which is very much clarified. Now we are setting all the 3 flags. Overflow flag has to set, carry flag has to set, auxiliary carry flag has to set. Let us look at one by one. When auxiliary carry flag will set, if there is a carry from D3 to D4, auxiliary carry flag will set. The content 89 and 88 will make, adding 89 and 88 will make the overflow, the carry to occur between D3 to D4, right? Once auxiliary carry flag will set, justified. So these 89 and 88 both are negative numbers because most significant bit is 1. When we are adding, it has become positive number, so overflow flag will set. And there is a carry from D7 to D8, so carry flag will also set. Fantastic, right? So let us look at it. Overflow, carry and auxiliary carry flag all will set. So carry flag was set, auxiliary carry flag was set, and overflow flag was set because of the 3 reasons. Positive number has become negative number has become positive number, hence overflow flag was set. There was a carry from D3 to D4, auxiliary carry flag was set, and there is a carry from D7 to D8, hence carry flag was also set. Fantastic, right? Okay, so now parity flag alone, right? Parity flag alone, doing the single step. Now parity flag alone, you can see number of ones after addition, number of ones is 1. There are odd number of ones. To compensate, parity flag will set and make the total count number of ones as even number, as you see here. Accumulator is 1 and R7 is 1. 1 plus 1 is 2. Hence parity flag alone sets. You can see here parity flag is set. Here you can see parity flag is set, which notifies that number of ones in the accumulator is 1. That is odd number. Number of ones in the accumulator is odd number. By setting the parity flag, number of ones has become even number. Okay. Here, number of ones is odd number. By setting, it has become even number. Parity alone. Now parity and auxiliary carry, as usual, now you are very much familiar. D3 to D4 carry, hence the auxiliary carry flag will set, and the number of ones in the accumulator is odd number, hence parity flag will set and notify it is even number. So now I am doing this, executing the 53rd, 54th and 55th line. Now it is executing 55th line. So adding to 8s will set both the parity flag and axillary carry flag. You can see will set the parity flag and axillary carry flag, because the number of ones in the accumulator is odd number, hence parity flag sets and make it as an even number. Number of there is a carry from D3 to D4, hence axillary carry flag sets and then notifies there is a carry from D3 to D4, hence axillary carry flag was also set. So parity and carry, number of ones in the accumulator is 1, odd number of ones. To make it as even number of ones, parity flag will set in this case. And when a carry flag sets, here there is a carry from D7 to D8, hence the carry flag will set in this operation. Just simple addition, right? Nothing is complicated in the program, because the focus is to understand the flags. So the programming is very much simplified by using the same instructions purposefully to make you comfortable. Okay, now doing single step. Accumulator is loaded immediately with C0. R7 is loaded immediately with C0. When we add these two, we are expecting the carry flag and parity flag to set. So the carry flag sets just because of there is a carry from D7 to D8, and parity flag sets just because of number of ones in the accumulator is odd number. You see 80 is in the accumulator, right? You see, look at the screen, look at the cursor. Accumulator contains 80, which is the sum. Number of ones is odd number. To make it as even number, parity flag will set. Why overflow flag didn't set? The input data is negative number because MSB is 1. The other data is also a negative number. Hence, when both the negative numbers are added, the sum is also a negative number because the most significant bit is 1. So there is no sign change. Hence, overflow flag did not set. That is also other interesting thing. Now the program counter is pointing 63rd line to check whether the parity carry and axillary carry is about to set or not. When axillary carry will set, and there is a carry from D3 to D4. Yes, purposefully we have made it as 80 to make the carry from D3 to D4. So axillary carry flag will set. When the carry flag will set, if there is a carry from D7 to D8, yes, there is a possibility for the carry from D7 to D8 when we perform addition. Okay, so carry will set. The number of ones in the accumulator is 1, 2, 3. When it is B0, number of ones are odd number of ones. To make it as even number of ones, parity flag will also set. Let us experience this. First instruction, moving the immediate constant C8 to the accumulator. Yes, C8 is in the accumulator. Now moving the immediate constant E8 to the register R7. E8 to the register R7 is fantastic. Adding the content of R7 with accumulator, we are getting the carry along with B0. So the answer should be B0 in accumulator. Yes, the accumulator content is B0. That is being shown here for comfortness. And what are the flags to be set? Axillary carry will set. Yes, axillary carry flag was set. And carry flag will set. Yes, carry flag was set. And the parity flag need to set. Why? Because the number of ones are odd number of ones, which is 1, 2, 3 in the accumulator. Hence the parity flag will sets and notifies that there is an odd parity, there is an even parity. Fantastic, great. And similarly checking for parity and overflow, number of ones after addition is odd number of ones, so parity flag will set and notifies and make it as even number of ones. Always it has to be even parity. And why overflow flag sets? Because two positive numbers are added, because MSB is 0, hence these two are positive numbers. But the sum gives the negative number because most significant bit has 1. Okay, so it is minus 128. Some two numbers was added, but sum has become minus 128. Hence 64. 40 means it is 64. 64 plus 64 plus 64 The sum is minus 128. So instead of plus 128, hence the overflow flag will set and then notify. Let us check this by executing the 68th line. By executing 68th line, moving the immediate constant for 40 to accumulator, yes. 40 will go to accumulator, yes. Accumulator contains 40. Then moving the immediate constant 40 to R7, yes, R7 will be loaded with 40. So accumulator is also 40, R7 is also 40. Adding the current of accumulator with R7, the sum is 80, which is positive number as will become negative number. Hence the overflow flag sets, and the number of ones is odd number of ones. Hence the parity flag is also set and then notifies that there are odd number of ones in the accumulator. Fantastic. Now all the three, parity, overflow, and axillary carry. Axillary carry, there is a carry from D3 to D4, hence axillary carry. Positive number has become negative number after addition, hence overflow flag. And the number of ones in the sum is 1, 2, 3, odd number of ones. So parity flag will set and then make it as even number of ones as usual. So moving the 48 to accumulator, moving 4C to the R7 register, adding these three. Axillary carry, parity flag, and overflow flag. All the three are set. Axillary carry, parity, and overflow flag. All the three were set as per the expectation. Where we are about to check carry, overflow, and parity. Carry, there is a carry from D7 to D8. Hence this flag will set. And overflow, negative number has become positive number, right? 81 is a negative number, 80 is a positive number. Sorry, 80 is also a negative number. By adding two negative numbers, the sum has become positive number. Hence sign change occurs. There is a sign change occurs. Hence overflow flag will set, and number of ones in the accumulator is odd number of ones. Hence parity flag will set and then notify. Let me do the single step execution. Yes, accumulator is loaded with 81, R7 is loaded with 80, and while adding, the accumulator content has to be 0, 1. You see, the accumulator content is 0, 1. So odd number of ones, hence parity flag sets, and negative number has become positive number, hence overflow flag was set. You see here, and there's a carry from D7 to D8, hence carry flag was set. Fantastic. So parity, overflow, and carry. Yes, parity, overflow, and carry. All the three flag was set. So fantastic. Now climax. All the four. Check all the four flags. Parity flag, overflow flag, carry flag, and axillary carry flag. Axillary carry D3 to D4. There is a carry 1 plus 1 is 0. Hence axillary carry flag will set. Carry flag. Yes, there is a carry from D7 to D8. There is a carry from D7 to D8, hence carry flag will set. The inputs are negative numbers because D7 is 1. So 88 is a negative number, other 88 is a negative number. Adding these two negative number, the sum has become positive number, so sign change occurs, hence overflow flag sets and notifies. And the number of ones in the accumulator is odd number of ones, which is only 1. So parity flag will set and then notify. The number of ones in the accumulator is odd number of ones. So all the four flags will set when we add 88 with 88. Fantastic, right? So accumulator will be loaded with 88 as you see here, and R7 will be loaded with 88 as you see here. And when we do the single step, so carry is 1, axillary carry is 1, parity is 1, overflow is 1. You see here parity, overflow, axillary carry, and carry.